Jee Advanced Solution Chapter question. In this question, we are given word is ideal solution. Given word is ideal solution. This ideal solution, it contains minimum two components. The two components are two liquids given, A liquid and B liquid. Out of these two, both are volatile liquids. Both are volatile liquids. Both are volatile liquids. Both are volatile liquids. A evaporates as well as B evaporates. Both exert vapor pressure. A is exerting vapor pressure, B is exerting vapor pressure. This solution obeys Raoults law. This solution obeys Raoults law. Raoults law says that vapor pressure of solution is equal to sum of the vapor pressures of components, vapor pressure of A plus vapor pressure of B. The vapor pressure of A is P naught A XA. Here XA is called mole fraction of A, P naught A is called vapor pressure of pure A plus P of B equal to P naught B XB. It is called vapor pressure of solution. It is Raoults law. This solution obeys Raoults law, so this formula can be applicable to this solution. Okay. This solution shows vapor pressure 700 torr. Here we have to take 700 torr we have to take. That solution shows vapor pressure 700 torr. 700 torr. It is distilled. So the solution is taken for distillation. Solution is taken for distillation. Distillation process, let us see. Here we are taking round bottom flask. In the round bottom flask we will take a ideal solution. This ideal solution, in this ideal solution volatile liquid A is present and volatile liquid B is present. It is distilled. It is distilled. We will get from here we will get two things. One is called distillate. One is called distillate. The distillate is also called condensate. Condensate. Another one is called residue. This on distillation. This solution on distillation gives distillate and residue. Now, this distillate contains what? Liquid A will be there and B will be there. Why? Because this solution is ideal. In the ideal solution, the components are volatile. All the components are volatile. Therefore, A evaporates as well as B evaporates. So, the distillate contains A and B. If boiling point of these two are different, any one will distillate, one will evaporate, another will be in the residue. Now, whether distillate contains both A and B or only A or only B, how to understand it? For which here given composition of condensate is mole fraction of A is equal to 0.75. Mole fraction of A in the condensate. Mole fraction of A in the condensate. Here, in this mole fraction of A is equal to 0.75 given. Mole fraction is 0.75 in the sense B also present. Therefore, here what is the amount of B? That is equal to 0.25 because sum of the mole fractions is equal to 1. This value indicates that the distillate contains A as well as B. Okay. And that of residue, mole fraction of A equal to 0.3. In the residue, mole fraction of A is given, that is equal to 0.3. This indicates mole fraction of B is equal to 0.7. So residue contains A as well as B. A as well as B. So this ideal solution on distillation gives distillate and residue. This distillate contains so and so, residue contains so and so. Next, this ideal solution is distilled for 2/3 of the solution is collected as condensate. So this is 2/3 of original solution, 2/3 of original liquid. 2/3 of original liquid is present here in the sense remaining 1/3 of original liquid will be residue. 1/3 of residue, 1/3 of original liquid will be residue. Okay. Next, if the vapor pressure of residue is 600 torr, this residue, vapor pressure of this residue solution is given 600 torr, given 600 torr. Now, 4 options given. Composition of original liquid as 0.6 or 0.4, P0A given, P0B given. Here, which of the following is or are true? That means more one option, otherwise more than one option also correct. Now let us solve this question. Here in the beginning you are taking in the round bottom flask original liquid you are taking. In the original liquid A as well as B present. In the original liquid A is present and B is present in this ideal solution. It is taken for distillation. You are getting a distillate and a residue. The distillate contains A as well as B. Residue also contains A as well as B. In the residue A as well as B is present. Okay. Now composition of A we have to say here. As per this option, composition of A here. That means mole fraction of A here we want. Mole fraction of A is nothing but number of moles of A by total number of moles here. Similarly, here mole fraction of A is given, that is 0.75. Here also mole fraction of A is given. We can relate mole fraction in terms of number of moles. We can relate mole fraction in terms of number of moles. Okay. Then given is vapor pressure of solution is given. Here 600 torr for residue vapor pressure, original liquid vapor pressure 700 torr. These two values given. Okay. We will take original liquid, that is 700 torr given. So vapor pressure of solution, vapor pressure of original solution, that is 700 torr, that is equal to P0A into mole fraction of A plus P0B into mole fraction of B. Now solution vapor pressure we know. We have to find P0A, we have to find P0B, we have to find. Mole fraction of this A we do not know. That's what they are asking. Mole fraction of this A and mole fraction of this A is given. So mole fraction of this A, if you want, we should know number of moles of this A and total number of moles. Then that means we have to say, we have to relate in terms of number of moles. We want mole fraction of A. See that mole fraction of A we want. P0A is required, P0B is required. All the terms are unknown. Then mole fraction of A we have to find it. Then only we can go for P0A and P0B. To find mole fraction of A, we want number of moles of A and total number of moles. So relate this mole fraction and this mole fraction in terms of number of moles. Sorry. We will consider a number of moles of A in the original liquid is X. This is the number of moles of A in the original liquid. It is equal to number of moles of A here, number of moles of A here, number of moles of A here, and number of moles of A here, number of moles of A here. That means number of moles of A in the original liquid is equal to number of moles of A in distillate plus number of moles of A in residue. Can we say this? Because this on distillation gives distillate and residue. How much A is here? In that some amount is here and some amount is here. Therefore, number of moles of A here is equal to sum of the moles of A in these two places. Okay. Now we have to substitute number of moles of A here. Sir, for this what is given? See, 2/3 of solution is collected as condensate. That means it is equal to 2/3 of this. It is equal to 2/3 of this. That means 2/3 of this one in the sense total moles. Therefore, we will see even B also. Even B also we will consider. So here B is equal to Y moles we will take. Here B number of moles is equal to, here B number of moles of B in the distillate plus number of moles of B in the residue. Now we will see here number of moles of distillate is 2/3 of original is X plus Y. Original is X plus Y. Here in the original liquid A is X moles, B is Y moles. So total moles in the original liquid is X plus Y. In that X plus Y, 2/3 is in distillate. 2/3 is in distillate. So remaining 1/3 is in residue. Remaining 1/3 is in residue. Remaining 1/3 is in residue. This is what 2/3 of total moles. 2/3 of this total moles is total distillate. 2/3 of total moles is total moles in the distillate. Now we want A alone. We want in this total moles, what is A? In this total moles, what is A? Mole fraction of A is given. Mole fraction of A is given, that is 0.75. Mole fraction is the fraction of A. So in this total, what is the fraction? 0.75 is the fraction of A. In this total, what is the fraction of A? 0.3 is the fraction of A. It is nothing but total moles of residue. In that A alone is how much? 0.3. Fraction is 0.3. In this way we will see here. Now 2/3 of original is total moles in distillate. 1/3 of original moles is total moles in residue. It is total moles in residue. In that, what is B alone? B is 0.7 fraction, because 0.3 is A, remaining 0.7 is B. In that way, it is total moles of distillate. In that, what is B alone? B alone is 0.25 fraction. 0.25 fraction, because 0.75 plus 0.25 equal to 1. Now we got X moles we got in this relation, Y moles we got in this relation. X is nothing but number of moles of A in original liquid, Y is nothing but number of moles of B in original liquid. Okay. Now we will go for this. Here P0 A is unknown value. X of A is called mole fraction of A in the original liquid. X of A is called number of moles of A in the original liquid by total number of moles in the original liquid, plus P0 B. X of B is called mole fraction of B. Mole fraction of B is called number of moles of B by total number of moles. Total number of moles. Now we will substitute the known values. 700 tar equal to this P0 A. It is unknown term, we have to find. Now X we will substitute. This X we will substitute from here. X is equal to so and so. So X is equal to 0.75 into 2/3 into X plus Y by X plus Y. Then P0 B into Y moles. Let us substitute Y moles from here. Y is equal to 0.25 into 2/3 into X plus Y plus 0.7 into 1/3 into X plus Y by X plus Y. Okay. Now X plus Y get cancelled. So 700 equal to P0 A into 0.75 into 2/3 plus P0 B into 0.25 into 2/3 plus 0.7 into 1/3. It is one relation. Another relation we will see. Now we will take residue. Residue vapor pressure is given as 600 torr. So residue vapor pressure is equal to P0 A into mole fraction of A. Mole fraction of A is how much? Mole fraction of A is given in residue 0.3 plus P naught B into mole fraction of B. Mole fraction of B is 0.7. Mole fraction of B is 0.7 because sum of these two is equal to 1. Now let us see this first equation and second. Now by solving 1 and 2, we can get P naught A, we can get P naught A as well as P naught B. Both values we can get. Using this P naught A and P naught B, what value we can get, that we will see. Now we will take this equation, we will take this 700 torr equal to this P naught A is this much, into mole fraction of A plus this P naught B equal to 500 torr into mole fraction of B, we can write as 1 minus mole fraction of A. From this we can calculate mole fraction of A in the original liquid, that is equal to 0.6. Hence option for this question is A, C and D.